Okay, good evening everyone. So last class we discussed about first chapter exercise of the few questions. Okay, remaining questions. Now today we are going to discuss about remaining questions. Okay. I think we discussed about this question. What is the difference between displacement and double displacement reaction? Right. Question number 12. Write one equation for each decomposition reactions. Where this we discussed. We discussed about question number 13. What is the difference between displacement and double displacement reaction? Okay. So just a second, few seconds. Okay. See the first question. So they're asking the question number 13. What is difference between displacement and double displacement reactions? Let me write first difference. So this is displacement, right? Right here. This is displacement. On this side we can write double displacement. Because the difference you see here. Here one metal will be there. Just for your understanding I'm saying. Let's say we're adding to salt. One. But here salt to metal. One from salt one. Here what we can say here, 2 salt will be there. Salt 1 plus salt 2. Here salt 3 plus salt 4. Okay. Here there is a condition. More reactive. More reactive metal should be there. Metal will be. Here there is no such condition. No such condition. Such metal, or what we can say here, what happening here, mutual exchange. What we can write here, exchange of ions. Okay, which case double displacement reaction, right? You can see here what I'm saying here. Hmm. See here, suppose if we are taking Fe plus CaSO4, so here you see Fe should be more reactive than copper, then only FeSO4 plus copper will form, right? But here we can see if I taken barium chloride plus sodium sulfate, here two salt we are taking here. Just both are exchanging here. Okay, both are exchanging. Then what happens here? NaCl plus barium chloride will sorry, barium sulfate will form. barium sulfate will come. And one more thing is you try to understand here. If I take in here Fe is 0, like oxidation state is 0, this is plus 2, this is minus 2, this is plus 2, this is minus 2, this is 0. You see oxidation here, tell what happening here? Oxidation, and similarly here, tell you see reduction. So we can say displacement reactions are redox reactions. Okay, here we can say non-redox. Why we can call non-redox? You see here, barium is here plus 2, here also it will be plus 2 only. Chlorine is minus 1, here also chlorine minus 1. Na is plus 1, here also plus 1 will be there. Minus 2, here also minus 2. No change in the oxidation number. This you should know. So redox and non-redox. Generally, this displacement reactions. So we taken displacement reactions are there. No? They are generally what we can say they are exothermic in nature. So what do you mean by exothermic nature, sir? It means energy is released. Energy will release in this case. Okay, what about here? May or may not be exothermic. Okay, may or may not be exothermic. Okay, here insoluble salt will form. Sometimes we know very well. Insoluble salt may form. Salt may form and such kind of double displacement again we are calling as what's that? Precipitation reaction. Here what we can say, no insoluble salt. Any difference we can write as our wish. Okay, if we have increased number of points, if you want to write. So next, let me come for the next refining question number 15. Refining of silver. This is here. What they given here. So in this, please try to when you are answering the question. Please underline some points. Refining silver means they want to they want to take silver outside. So already by process, you know very well some kind of process are like reduction and all. After all doing those all things, what they are doing, still there will be a small amount of impurities. So to remove them, that they will use a process called refining. Okay, so this recovery of silver from the silver nitrate solutions involved in the displacement by the copper metal. Write down the reactions involved. They're asking reactions. So let me write here question number, so this is question number 14, right? So question number 14, you can write here question number 14. They're asking why they're saying that AgNO3 is there. So in AgNO3, we want to take this Ag outside. That is, they are saying they are using copper because you see here, when we are taking the reactive series, we know very well potassium, more reactive than the sodium, then we have calcium, then we have magnesium, then aluminium, zinc, iron Fe, plus then we have think lead, we have then hydrogen, then copper, then mercury, then silver, Ag, and then we have gold. So this is what given in the NCRT. Many are there, just you can follow this one. You see here, here is copper and here is silver. So which is more reactive as per the series? We can say copper is more reactive than the silver. That's why they will use the copper so that copper can displace silver from the silver nitrate. Okay, then what happens here? In the place of this silver, copper will come. So it will form CuNO3 taken twice plus Ag. Ag will get separated. Will be what is the color? Sir? Silvery gray will be there. Silvery we can say not silvery gray. So silvery color. Then what is the color of this copper? Sir? It will be a brown color metals. Then after this basically this copper compound is what we can say bluish green color. So blue to green color salt solutions will form. So upon this copper metal, we can see that there is deposition of silver metals and solutions will turn to this one. So you can write aqueous solutions, or we can say molten. Let me see solid. This will be an aqueous. This will be an salt. Okay. So question number, this is question 14. Discuss question number 15. Question number 15, what they're asking, what do you mean by the precipitation reaction? Explain by giving the example. So you know very well precipitation reaction is what, sir? So precipitation reaction is question number 15. Okay. Question number 15 here. Question number 15, precipitation reaction. You see, do we know about double displacement reaction? Question number 15, double displacement reactions. Double displacement reaction. Okay. Reactions are there. Double displacement reaction. So generally, if I take an example like barium chloride, aqueous solution of barium chloride react with aqueous solution of aluminum sulfate, Al2SO4 taken thrice. Okay, these two salts if you are taken, then what happens are exchange of ions. This is plus 2 will form, this is minus 1, this is plus 3 aluminum, this is minus 2. In the place of barium, aluminum will form aluminum chloride AlCl3 plus this is aqueous solution. This is barium sulfate. This barium sulfate is what, sir? It is an solid. You should write represent with the downward arrow mark. So insoluble solid. Insoluble. Insoluble solid is formed in the double displacement reaction. That solids is called precipitate. They will call it precipitate. And such kind of reactions are called what, sir? They will call precipitation. Precipitation reaction. So precipitation reaction is nothing but what, sir? It's an double displacement reaction in which one of the product is insoluble solid. It is a, remember, it is a white color insoluble. Wherever barium sulfate is, it will be a white color insoluble solid. This kind of reaction, double displacement reactions are called. But we can say it is an precipitation reaction. Next question you see. Question number 16. Explain the following terms of gains or in terms of gains or loss of oxygen with the two example. The two example each. So oxidation and reduction. In terms of loss of oxygen and gain of oxygen should explain. So you can say, so I will take example here. Question number 16, right? Question number 16. Question number 16, I can take example question number 16. Okay, so we can take an example, copper oxide plus H2 gives rise to copper plus H2. This is an example. What we can say, one more example, we can say copper plus oxygen gives rise to copper oxide. So they're asking two examples for oxidation. I'll say these two are examples for the oxidation. Same example we can give for the reduction. Why? Because wherever oxidation there will be definitely reduction. You see here from here to here, what we can say? We can say we added oxygen for the copper. So I can say in this process, I can say oxidized. Copper oxidized to what's that? Oxidized to copper oxide. Clear? This is example for oxidation. Similarly, in this you see, this one which one is oxidized, sir? You can say hydrogen here. So for hydrogen we added oxygen. I can say in this second hydrogen H2 oxidized towards H2O. This is one example. For this, which ones are? These two are example for oxidation. See, same equation you can use for the reductions. Anyway, let me write other examples also. Okay. So now I will write here another equation. Unique example I can say reduction. You can see I will write the reduction. We have zinc oxide plus we are reduction of zinc oxide. So I can get the zinc plus carbon monoxide, carbon dioxide, I think. Okay. Now here do you see carbon? Here to here what happens? Yeah. Let's see here. In this process, we remove the oxygen. So removal of oxygen, I can say zinc oxide reduced. Zinc oxide reduced to Zinc. Don't write zinc is reduced or carbon is reduced. You try to understand. Zinc oxide is reduced in here. This is very, very important. Similarly, I can say one more example we have no? MnO2 plus HCl. MnO2 plus HCl gives rise to MnCl2 plus Cl2 plus H2. I think so. Here I can say here in terms of oxygen side, you can say here I can say there is an removal of oxygen. I can say MnO2 reduced to also MnCl2. Okay, so here you see actually this is plus 4 is there, it reduces to plus 2. Okay, I already discussed that. We discussed that last few days back. We discussed the class that suppose decreasing in the charge. Suppose here we have 0, this will be plus 1, this is plus 2, this is plus 3, this is plus 4, plus 5. Okay, if we are moving in a positive direction, increasing in charge, we can say oxidation, right? Oxidation. Similarly, if we are moving minus 1, minus 2, minus 3, minus 4, okay, in this direction it is called reduction. You can see it is called reduction. So what I am saying here, you can see here Mn plus 4 was in the MnO2. In MnO2, you see it have a oxidation state of plus 4. Now it becoming what's it becoming Mn plus 2 in terms of what's are in the case of MnCl2. This is plus 2. So you can say plus 4 to plus 2 direction is decreasing in charge. That's why it is undergoing reduction process. So anyway, removal of oxygen. This is question number 16. Question number 17. 17 you can write a shiny brown color. A shiny brown color element X is brown color. This is an important question actually. Shiny brown colored element X, and on heating with an air becomes an black in the color. Name the element X and black colored compound found here. So we're even given the word int here. This is question number 17. Let me see the question number 17. Okay. So question number 17 it is. Some other color we can. Now see here. Shiny this X is there. What is the int they given? So they given shiny brown element. This is int. Shiny brown we can say it will be an copper. Which element it is copper. Similarly see here. Copper element eating in air. Eating in air means what, sir? Means they're adding oxygen. Okay, oxygen they're adding. So what happens, sir? Copper is there plus oxygen they added here. So surface of the powder it will become CuO. It will become copper oxide. It becomes copper oxide. Okay, so it is which color? That is black color. What is about this one, sir? This is brown color. So can you guess what is this process? Oxygen is added here. What kind of example is this? We can say it will be an oxidation. So copper is undergoing oxidation. Okay. So you can see this activity. Let it remind this activity. You can see here they given this brown color. This is Cu metal, and here they are supplying heat energy. So the surface of this downside, whatever is there, it is copper. They are supplying heat energy becomes copper oxide. Copper to oxide. Copper to oxide means oxidation state of copper is Cu2 oxide. Cu means it is plus 2, this will be minus 2. What kind of process it is secant copper to oxide they given, okay? This activity brown color metal, okay? Next question you see. Next question. Next question, you can see there. Next question. Question number 18. Why do we apply paint on the iron article? Simple. Right here only answer. To avoid what's up? To avoid corrosion. To avoid corrosion, or you can say rusting. Okay. Iron article is for rusting, no? You can say. Oil and fats and containing food items in the flesh, because here, see, oil and food items contain fats. Contains fats. Question number 19. Just 19. Okay. Fats will react with oxygen. Will undergo what's the oxidation process. So to avoid oxidation process, what happens? Suppose they are filled with this inert gas N2, will not react with this food. So nitrogen gas is inert. Okay, which will help. Right here better. This so fats will undergo oxidation with water, with the air. Okay, but as N2 is inert, inert gas will help us to avoid oxidation. It, it will not react with the food, or we can say fat. Okay, now see here. Last question, I think. Question: explain the following terms with example of each. Corrosion density. So corrosion means what's that? Within the corrosion. Question number 20 or 21. 20. So what in the corrosion is we have Fe react with O2 plus H2 forms Fe2O3 dot X number of H2O. Okay. So metal is undergoing which process? That is adding oxygen. They are undergoing what's the oxidation process. So oxidation of what we can say metals is called generally corrosion. Okay. Similarly, rancidity means what's that? Rancidity means nothing but food. Fat is reacting with oxygen forms is undergoing oxidation. This is called we can say spoiling, spoiling of food and getting bad smell because of what's the smell, or we can say example of what's the process. Oxidation is an example for what's rancidity. So now with this, by this we can end the chapter of chemical equation and reaction. Okay, so at the afterwards we can take previous year questions, means last 10 year questions we discuss. Okay, so thank you for everyone.